The Maya calendar is a system of calendars used in pre-Columbian Mesoamerica, and in many modern communities in the Guatemalan highlands, Veracruz, Oaxaca and Chiapas, Mexico. The essentials of the Maya calendar are based upon a system which had been in common use throughout the region, dating back to at least the 5th century BCE. It shares many aspects with calendars employed by other earlier Mesoamerican civilizations, such as the Zapotec and Olmec, and contemporary or later ones such as the Mixtec and Aztec calendars. By the Maya mythological tradition, as documented in colonial Yucatec accounts and reconstructed from late Classic and post-Classic inscriptions, the deity Itzamna is frequently credited with bringing the knowledge of the calendar system to the ancestral Maya, along with writing in general and other foundational aspects of Maya culture. Overview. The Maya calendar consists of several cycles or counts of different lengths. The 260-day count is known to scholars as the Zocan, or Zocon. The Zocan was combined with a 365-day vague solar year known as the Harb to form a synchronized cycle lasting for 52 Harb, called the calendar round. The calendar round is still in use by many groups in the Guatemalan highlands. A different calendar was used to track longer periods of time, and for the inscription of calendar dates. This is the long count. It is a count of days since a mythological starting point. According to the correlation between the long count and Western calendars accepted by the great majority of Maya researchers, this starting point is equivalent to August 11, 3114 BCE in the proleptic Gregorian calendar or the 6th of September in the Julian calendar. The GMT correlation was chosen by John Eric Sidney Thompson in 1935 on the basis of earlier correlations by Joseph Goodman in 1905, Juan Martinez Hernandez in 1926, and Thompson himself in 1927. By its linear nature, the long count was capable of being extended to refer to any date far into the past or future. This calendar involved the use of a positional notation system, in which each position signified an increasing multiple of the number of days. The Maya numeral system was essentially vigesimal, and each unit of a given position represented 20 times the unit of the position which preceded it. An important exception was made for the second-order place value, which instead represented 18 times 20, or 360 days, more closely approximating the solar year than would 20 times 20 equals 400 days. It should be noted, however, that the cycles of the long count are independent of the solar year. Many Maya long count inscriptions contain a supplementary series, which provides information on the lunar phase, number of the current lunation in a series of 6 and which of the 9 lords of the night rules. Less prevalent or poorly understood cycles, combinations and calendar progressions were also tracked. An 819-day count is attested in a few inscriptions. Repeating sets of 9 days associated with different groups of deities, animals, and other significant concepts are also known. Zocan. The Zocan is the name commonly employed by Mayanist researchers for the Maya sacred round or 260-day calendar. The word Zocan is a neologism coined in Yucatec Maya to mean count of days. The various names of this calendar as used by pre-Columbian Maya peoples are still debated by scholars. The Aztec calendar equivalent was called Tonalpouli in the Nahuatl language. The Zocan calendar combines 20-day names with the 13-day numbers to produce 260 unique days. It is used to determine the time of religious and ceremonial events and for divination. Each successive day is numbered from 1 up to 13 and then starting again at 1. Separately from this, every day is given a name in sequence from a list of 20-day names. Some systems started the count with 1 Imix, followed by 2 Ik, 3 Akbal, etc., up to 13 Ben. The day numbers then start again at 1 while the name day sequence continues onwards, so the next days in the sequence are 1 Ix, 2 Men, 3 Kib, 4 Kaban, 5 Etznab, 6 Kawak, and 7 Ajor. With all 20 named days used, these now began to repeat the cycle while the number sequence continues, so the next day after 7 Ajor is 8 Imix. The repetition of these interlocking 13 and 20-day cycles therefore takes 260 days to complete. Hab. The Hab was made up of 18 months of 20 days each plus a period of 5 days at the end of the year known as Wayab. The 5 days of Wayab were thought to be a dangerous time. Foster writes, during Wayab, portals between the mortal realm and the underworld dissolved. No boundaries prevented the ill-intending deities from causing disasters. To ward off these evil spirits, the Maya had customs and rituals they practiced during Wayab. For example, people avoided leaving their houses and washing or combing their hair. Bricker estimates that the Hab was first used around 550 BCE with a starting point of the winter solstice. The Hab month names are known today by their corresponding names in colonial-era Yucatec Maya as transcribed by 16th-century sources. Phonemic analyses of Hab glyph names in pre-Columbian Maya inscriptions have demonstrated that the names for these 20-day periods varied considerably from region to region and from period to period, reflecting differences in the base language and usage in the Classic and post-Classic eras predating their recording by Spanish sources. Each day in the Hab calendar was identified by a day number in the month followed by the name of the month. Day numbers began with a glyph translated as the seating of a named month, which is usually regarded as day 0 of that month, although a minority treat it as day 20 of the month preceding the named month. In the latter case, the seating of Pop is day 5 of Wayab. For the majority, the first day of the year was 0 Pop. This was followed by 1 population, 2 Pop as far as 19 Pop, then 0 Wo, 1 Wo, and so on. The Hab year had exactly 365 days, and ignored the extra quarter of day in the actual tropical year. This meant that the seasons moved with respect to the calendar year by a quarter of a day each year, so that the calendar months named after particular seasons no longer corresponded to these seasons after a few centuries. Calendar round. A calendar round date is a date that gives both the Zocan and Hab. This date will repeat after 52 Hab years or 18,980 days, a calendar round. For example, the current creation started on 4 Ahau 8 Kumu. When this date recurs it is known as a calendar round completion. Arithmetically, the duration of the calendar round can be explained in various ways. One way is to consider that the least common multiple of 260 and 365 is 18,980. Not every possible combination of Zocan and Hab can occur. For Zocan days Imix, Kimi, Quen and Kib, the Hab day can only be 4, 9, 14 or 19. For Ik, Manik, Eb, and Kaban, the Hab day can only be 0, 5, 10 or 15. For Akbal, Lamit, Ben and Etznab, the Hab day can only be 1, 6, 11 or 16. For Kan, Muluk, Ix and Kawak, the Hab day can only be 2, 7, 12 or 17, and for Chikshon, OK, Men and Ador, the Hab day can only be 3, 8, 13 or 18. Year bearer. A year bearer is a Zocan day name that occurs on the first day of the Hab. If the first day of the Hab is 0 Pop, then each 0 Pop will coincide with a Zocan date. For example, 1 Ik 0 Pop. Since there are 20 Zocan day names and the Hab year has 365 days, the Zocan name for each succeeding Hab 0 day will be incremented by 5 in the cycle of day names like this. 1 Ik 0 population 2 Manik 0 population 3 Eb 0 population 4 Kaban 0 population 5 Ik 0 Pop. Only these 4 of the Zocan day names can coincide with 0 Pop, and these 4 are called the year bearers. Year bearer literally translates a Mayan concept. Its importance resides in 2 facts. For one, the 4 years headed by the year-bearers are named after them and share their characteristics, therefore, they also have their own prognostications and patron deities. Moreover, since the year-bearers are geographically identified with boundary markers or mountains, they help define the local community. The classic system of year-bearers described above is found at Tikal and in the Dresden Codex. During the late Classic period, a different set of year-bearers was in use in Kamcha. In this system, the year-bearers were the Zokan that coincided with one pop. These were Akbal, Lamit, Ben and Edenab. During the post-Classic period in Yucatan, a third system was in use. In this system, the year-bearers were the days that coincided with two pop, Kan, Muluk, Ix and Kawak. This system is found in the Chronicle of Oxkutskab. In addition, just before the Spanish conquest in Mayapan, the Maya began to number the days of the Harb from 1 to 20. In this system, the year-bearers are the same as in the one-pop Kamcha system. The classic year-bearer system is still in use in the Guatemalan highlands and in Veracruz, Oaxaca, and Chiapas, Mexico. Long count. Since calendar round dates repeat every 18,980 days, approximately 52 solar years, the cycle repeats roughly once each lifetime. So a more refined method of dating was needed if history was to be recorded accurately. To specify dates over periods longer than 52 years, Mesoamericans used the long count calendar. The Maya name for a day was Kayan. 20 of these Kayans are known as a winal or uinal. 18 winals make 1 ton. 20 tons are known as a kachan. 20 kachans make a biak ton. The long count calendar identifies a date by counting the number of days from the Mayan creation date for Ahor, 8 Kumu. But instead of using a base 10 scheme like Western numbering, the long count days were tallied in a modified base 20 scheme. Thus 0.0.0.1.5 is equal to 25, and 0.0.0.2.0 is equal to 40. As the winal unit resets after only counting to 18, the long count consistently uses base 20 only if the ton is considered the primary unit of measurement, not the Kayan, with the Kayan and winal units being the number of days in the ton. The long count 0.0.1.0.0 represents 360 days, rather than the 400 in a purely base 20 count. There are also 4 rarely used higher-order cycles: Pictun, Kalabtun, Conchiltun, and Alautun. Since the long count dates are unambiguous, the long count was particularly well suited to use on monuments. The monumental inscriptions would not only include the 5 digits of the long count, but would also include the 2 Zokan characters followed by the 2 Harb characters. Misinterpretation of the Mesoamerican long count calendar was the basis for a popular belief that a cataclysm would take place on December 21, 2012. December 21, 2012 was simply the day that the calendar went to the next biak tons at long count 13.0.0.0.0. The date on which the calendar will go to the next pictons at long count 1.0.0.0.0 will be on October 13, 4772. Sandra Noble, Executive Director of the Mesoamerican Research Organization Foundation for the Advancement of Mesoamerican Studies, Inc., notes that, for the ancient Maya, it was a huge celebration to make it to the end of a whole cycle. She considers the portrayal of December 2012 as a doomsday or cosmic shift event to be a complete fabrication and a chance for a lot of people to cash in. Supplementary series. Many classic period inscriptions include a series of glyphs known as the supplementary series. The operation of this series was largely worked out by John E. Teeple. The supplementary series most commonly consists of the following elements. Lords of the Night. Each night was ruled by one of the 9 Lords of the Underworld. This 9-day cycle was usually written as 2 glyphs. A glyph that referred to the 9 lords as a group, followed by a glyph for the lord that would rule the next night. Lunar series. A lunar series generally is written as 5 glyphs that provide information about the current lunation, the number of the lunation in a series of 6, the current ruling lunar deity, and the length of the current lunation. Moon age. The Maya counted the number of days in the current lunation. They used 2 systems for the 0 date of the lunar cycle, either the first night they could see the thin crescent moon or the first morning when they could not see the waning moon. The age of the moon was depicted by a set of glyphs that Mayanists coined glyphs D and D. A new moon glyph was used for day 0 in the lunar cycle. D glyphs were used for lunar ages for days 1 through 19, with the number of days that had passed from the new moon. For lunar ages 20 to 30, an E glyph was used, with the number of days from 20. Count of lunations. The Maya counted the lunations. This cycle appears in the lunar series as 2 glyphs that modern scholars call the C and X glyphs. The C glyph could be prefixed with a number indicating the lunation. No prefixing number meant 1, whereas the numbers 2 through 6 indicated the other lunations. There was also a part of the C glyph that indicated where this fell in a larger cycle of 18 lunations. Accompanying the C glyph was the X glyph that showed a similar pattern of 18 lunations. Lunation length. The synodic period of the moon is 29.53059 days. As a whole number, the number of days in a lunation will be either 29 or 30 days. The Maya wrote whether the lunar month was 29 or 30 days as 2 glyphs. A glyph for lunation length followed by either a glyph made up of a moon glyph over a bundle with a suffix of 9 for a 29-day lunation, or a moon glyph with a suffix of 10 for a 30-day lunation. Since the Maya didn't use fractions, lunations were approximated by using the formula that there were 149 lunations completed in 4,400 days, which reduces to 29.5302 days. 819-day count. Some Mayan monuments include glyphs that record an 819-day count in their initial series. These can also be found in the Dresden Codex. This is described in Thomson. More examples of this can be found in Kelly. Each group of 819 days was associated with one of 4 colors, and the cardinal direction with which it was associated. Black corresponded to west, red to east, white to north, and yellow to south. The 819-day count can be described several ways. Most of these are referred to using a Y glyph and a number. Many also have a glyph for Kawil, the god with a smoking mirror in his head. Kawil has been suggested as having a link to Jupiter. In the Dresden Codex Almanac 59 there are checks of the 4 colors. The accompanying texts begin with a directional glyph and a verb for 819-day count phrases. Anderson provides a detailed description of the 819-day count. Short count. During the late Classic period, the Maya began to use an abbreviated short count instead of the long count. An example of this can be found on altar 14 at Tikal. In the kingdoms of post-classic Yucatan, the short count was used instead of the long count. The cyclical short count is a count of 13 kachins, in which each kachin was named after its concluding day. Ahau. One imix was selected as the recurrent first day of the cycle, corresponding to one Cipactli in the Aztec day count. The cycle was counted from Katun 11 Ahau to Katun 13 Ahau, with the coefficients of the Katuns concluding days running in the order 1 1, 9, 7, 5, 3, 1, 1 2, 1 0, 8, 6, 4, 2, 1 3 Ahau. The concluding day 13 Ahau was followed by the re-entering first day 1 imix. This is the system as found in the colonial books of Chilambalam. In characteristic Mesoamerican fashion, these books project the cycle onto the landscape, with 13 Ahau lordships dividing the land of Yucatan into 13 kingdoms.